Imagine trying to understand how quickly water flows through the ground, perhaps to predict a well's output or map a contaminant plume. It is a complex challenge, and hydrologists often relying on to critical concepts to unlock these secrets. The fundamental difference between transmissivity and hydraulic conductivity lies in scale. Hydraulic conductivity describes how easily water moves through a specific porous material, while transmissivity tells us how much water can move through an entire saturated aquifer of a certain thickness. At its core, hydraulic conductivity, often denoted by the letter K, is an intrinsic property of the porous medium itself. It quantifies the ability of a material, like sand or clay, to transmit water, factoring in the properties of the fluid and the medium's pore characteristics, such as their size, shape, and interconnectedness. Its units typically reflected a velocity, for example, meters per day or feet per day. Transmissivity, symbolized by the letter T, takes this a step further by considering the full saturated thickness of an aquifer. It is calculated by multiplying the hydraulic conductivity of the aquifer material by the aquifer's saturated thickness, and its units are consequently length squared per time, such as meters squared per day. This means you would use hydraulic conductivity to characterize a specific layer of soil or rock in a laboratory setting, or when dealing with small-scale flow problems. For instance, determining if a certain clay layer would be effective as a barrier to groundwater flow relies on its hydraulic conductivity. On the other hand, you would apply transmissivity when analyzing regional groundwater flow, designing pumping tests for wells, or estimating the total volume of water an aquifer can supply. A pumping test, for example, often yields a direct estimate of transmissivity because it reflects the aquifer's ability to transmit water over a larger area. Understanding this distinction is vital because it dictates how we model and manage our precious groundwater resources. Transmissivity provides a simplified, yet powerful, parameter for understanding the overall capacity of an aquifer to convey water horizontally, treating the entire saturated layer as one unit. This greatly streamlines calculations for larger hydrogeological assessments, helping us predict the movement of water and dissolved substances over significant distances. Ultimately, grasping the roles of both hydraulic conductivity and transmissivity empowers hydrologists and engineers to perform more accurate assessments of groundwater systems. This dual perspective ensures we can effectively manage water supplies, predict contaminant migration, and design infrastructure with a deeper comprehension of the subterranean world.
If you love learning about water, like, subscribe, and keep exploring with us.